everyone, myself Professor Borat AD, and today we are going to learn a new practical, that is single phase power measurement. In a given experiment we use the following resources. Here we have an ammeter. As you can see, in a scale we have two scale, 0 to 5 and 0 to 10, and here you can see three knobs. One is common, one for 10 ampere and one for 5 ampere. Here we use a common and 10 ampere. This is our wattmeter. As you can see, wattmeter, we have a M, C, and this for two terminal for voltage, and here one terminal for load. We connected this this link is used to measure current. As you can see, here we link connected in parallel. It means B1 and E2, B2 and E1, so that this wattmeter is set up for 10 ampere, and during experiment we use a 300 volt. Okay, and this is our multimeter. Here we multimeter act as a voltmeter. So let's start with the connections. Before connections, let's check out the circuit diagram. As you can see in a circuit diagram, phase starts from supply and connected to the ammeter. Then ammeter's second terminal is connected to the M terminal of wattmeter. As you can see here, M and C is short circuited. Okay, then the L terminal of a wattmeter is connected to the load. Here you can see the second terminal of the load, and the V terminal of the wattmeter is short circuited, and then this terminal again goes to the neutral side of supply. Let's start connections. Okay, here we connected a red wire to the phase. Then second terminal of this wire is connected to the ammeter's common. Here you can see. The red wire second terminal is connected to the common of ammeter. Here we connected it. Make sure the connection is proper. There is no loose contact. Then, as you can see in the circuit diagram, the second terminal of ammeter is connected to the M. Here we use a 10 ampere. Here we use a 10 ampere. Okay. Then, as you can see in the circuit diagram, ammeter second terminal is connected to the M. Okay, it may be happen sometimes, so make sure it is proper connected. Okay, then as you can see in the circuit diagram, M and C get shorted. So here we M and C for common, shorted. Okay, then as a circuit diagram you can see the L terminal is goes to the one terminal of load. So we connected. Make sure take a proper length of wire. Here is the L terminals. Then again this, okay, doesn't matter. L terminal of the load. Okay, then it connected to the phase of a load. Okay, then what will happen? The V terminal of a wattmeter and the load terminal, second terminal, is get short circuited. Okay, so we connected. Then you check out here, the load second terminal and the wattmeter's V terminal get short circuited. Here we can see wattmeter's V, that is 300 volt, and load second terminal it's short circuited. Okay, and as you can see, then this terminal moves to the neutral side of the supply. Here we connected a neutral side of supply. Okay, once again make sure the connection is proper. Okay, this way we connected a circuit diagram for a single phase power measurement. This is our observation table. As you can see, in first column we write as a serial numbers. In second column we have written a ammeter reading. In third column we have written a voltmeter reading. Then calculated power, and the formula for that is V into I into cos phi, where cos phi stands for power factor. Okay, then this is our wattmeter reading, and the last one is the actual power. It means W into MF. MF stands for multiplying factor, and W it means the wattmeter reading. Okay, so let's start it. First we start supply. Okay, when we start supply, we show an indicating lamp. Then here is a multimeter. Multimeter acts as a voltmeter. We put a multimeter for 600 volt. Okay. Here you can see supply is 235. Okay, so let's start reading. For take a reading, we start a first button of load. Okay, load started. Our voltmeter reading is 230 volts. Ammeter reading is 1.9. Here we take a upper scale. Okay, notice it. Here we take a upper scale. It means 0 to 10. Okay, the reading is 1.9. Ammeter reading 1.9. Okay, then wattmeter reading is, it is approximate to 200. Okay, we have taken one reading, then we have take the second one. Okay, then again take ammeter reading. Ammeter reading, here you can see, here is a 1.5 and here is 2. The ammeter reading is 3.6. Okay, note down here. Then voltmeter reading, here we get a 229. And the wattmeter reading is 400. Okay, then take another reading. Okay, we have taken the readings. Now we move to the calculations. The main point is what is meant by multiplying factor. The formula for the multiplying factor is CR. It means the current rating into voltage rating into the power factor divided by full scale deflections. Okay, we have a current rating for wattmeter 10 ampere, for voltage rating 300 volt, and our power factor is 1, and full scale deflection as you can see here 1400. Okay, and our multiplying factor is 2. And in a observation table you can see the formula for calculated power is V into I into cos phi, and for actual power W it means wattmeter reading into the multiplying factor. Okay, so this 2 column is for calculations, and here we take our observations. Okay, in this way we completed our practical for single phase power measurement. Thank you.